and other language related skills like UVM, test bench development, test case development, and test case management, and regression analysis, regression report generation. Those all things we need to do we need to make automation by using scripting languages like Python or Perl. We here in this course we are covering the Python because if we talk about 5 to 10 years back, mostly mostly in companies they use Perl. Mostly in companies they use Perl scripting, but nowadays everyone switched to the in new projects. In legacy projects they are using still they are using the Perl, but in new projects they are changed to Python because Python offers many inbuilt libraries for handling different day-to-day tasks, for handling different day-to-day repeated tasks. When coming to design verification, we have many repeated tasks. Like for developing UVM-based test bench, we have many repeated
Puneet,
syntax. So if we take, for example, to develop a test bench at SOC level, we have multiple IPs. For each IP, we need to target we need to create the test bench like agent for each interface. In each agent, there are multiple components, and across all IPs, the test bench is more or less similar, more or less looks similar. Agent, driver, monitor, subscriber. So these all components, only the naming convention will be changed. Names will be changed. So by using Python scripting, we can automatically develop those type of test benches, UVM based test benches. And the main intention is to speed up the overall product development stage. And we need to focus more on the verification, like finding out the protocol debugs, analyzing the test cases, what are failing, what are passing, and remaining repeated tasks we will do by using the Python automation. Next, by using the Python automation, we can increase the overall productivity, and error reduction. If we manually code complete test bench for whole SOC, there is lot of errors. It prone to lot of human errors. So to reduce, we will use the Python for developing automatic test bench code. And yeah, for improving the coverage, we will create the coverage analysis tools to analyze at what percent coverage is covered, what percent coverage is achieved, and we will create the minimum criteria to close the coverage. So if not achieved that much coverage, we will make a particular list targeting the those test cases not reaching the particular coverage criteria. So scripting will make debugging easy. Next, yeah, we will create the customizable scripts. Means we can use the script across the projects, and we can automate the design verification tools, EDA tools like VCS, Quasta Sim, and we can analyze the regression simulation outputs like regression files, pass fail cases of test cases, and sign off criteria is reached or not. So those for observing that we will use the Matplot, Pandas dashboard. And regression means we're simulating all the test cases, and after that we will analyze the log files by using log file parsing by different Python inbuilt libraries. So overall, it will help us to enhance our skill set, increases the efficiency, and it will value added to your resume. Yeah, now we will talk about where exactly we are using the Python in functional design verification flow. In design verification flow, first we need to read the specification. We need to understand the specification. And let's say for understanding, we will take SPA host specification. And SPA host has the internal registers, 200 internal registers. So for all registers, All registers, to define all registers, we need to follow the same syntax. We need to use the UVM RAL base class, UVM register base class for defining each test case and for creating object and configuring with the default specification values. For each register definition, the coding is similar. So by using the Python, we can automate we can automate the RAL code generation. We can automate the RAL code generation, and we have in industry we have the tools called RALGen, and we need to give input. We need to give all the input register names, default configuration values to some file. There will be file extract file, and for different tools we need to give different format, different file format as the input, and in that file format we need to give all the register names, register detail, all the register details. The tool will generate the SPR RAL model. So, but in few projects, if we required any customized coding, that time we will use the scripting languages like Parallel the Python. In our course, we are covering Python. By using Python, we will automatically generate SPI register model. SPI register model. By reading the SPI specification, we will list out all the registers and register default values, and we will generate the RAL model, UVM RAL model for SPI host. And test plan, all the test cases, the skeleton is same. The skeleton is same like body and body. In each sequence, body and body, and there are repeated things we will code in all the test cases. So we will create a Python based template for test case generation and sequence generation. By using Python, we can generate the skeleton of sequences and test cases. The test case development engineer just need to focus on the logic part. Just need to focus on the logic part, and it will also reduce the errors. Next, test bench development. So let's say we have the SOC project. In SOC project, we have 30 IPs, 30 IPs, 30 IPs, and each IP has one interface, one interface. So you required 30 agents. You required 30 agents, 30 UVM agents, and in each agent there is a common thing like driver, monitor, sequencer. So UVM for each interface, overall UVM test bench is similar across each IP. The UVM test bench is similar. So to repeat this task, we use Python. We will use Python, and Python will automatically generate test bench for this 30 IPs. Test bench for this 30 IPs and top level TB, everything, all the IPs, how all IPs are connected. So everything, overall test bench hierarchy, we will generate by using Python scripting. Next, in simulation time, we need to do the compilation. We need to invoke the tool, invoke different types of tools like VCS, FastaSim, and based on the tool, we need to adjust the point. We need to customize our script, and we will automate to invoke the different EDA tools like VCS, FastaSim, Xilium, and yeah, in our test bench we have, suppose we have the thousand test cases. So we need to each time we need to run one test case. We need to run one test case. For each test case, there will be the log files and coverage reports. And in log file, we have the pass fail criteria. And based on the pass fail condition, we need to debug. We need to debug. And let's say we have the thousand test cases. And to do the repeated task, like each test case running and analyze, checking whether test case is failed or passed. For each test case, we have thousand log files. For thousand test cases, we have thousand log files. Each test case we need to open, we need to check whether test case passed or failed. So it is the repeated task, right? for thousand test cases, we need to open 1,000 times. And let's say out of thousand test cases, out of thousand test cases, uh, out of thousand test cases, 600 test cases are passed. 600 are passed and 400 are failed. 400 are failed. And but without using any scripting, we need to open 6,000 test cases and we need to figure out what test cases are failed. And after figuring out, we need to open that, we need to analyze and debug those failed test cases. But by using the scripting, we can filter out what are the test cases failed, and for each test case, how much simulation execution time is taken, and whether it is taking more than intended execution time for the each test case. So those all things we need to filter out from the log files, and we will generate a reports. We will generate the reports like HTML report, CSV report, and web application based reports. So it will make overall task repeated tasks easy. Overall repeated tasks easy, and it will reduce overall debugging time because we need to focus mainly on debugging. We need to focus mainly on debugging. So for that, for setting up regression, we will use Python and Makefile. Python and Makefile, and Python and Makefile we will customize. We will customize like to set up the full regression, to set up the nightly regression, to set up weekly regression, and sanity tests. So for everything, we will customize the Makefile and Python script, and we can also for debugging what are the test case failed. For suppose test case one is failed, we need to open the waveform for test case one. So that time we will include the targets in the Makefile, and just by giving the test case the tool will automatically open the waveform related to the test case. So then we will debug the test case and we will again include in the test suite and we will run the regression. So this whole thing we will automate by using the Python scripting and coverage also for each test case we will get the coverage. And finally, after regression, we need to measure all the coverage that we will do by using script coverage merging we will do in the regression testing we already discussed, and debugging also we will customize the script for debugging each test case, for running all test cases, sanity test cases, smoke test, nightly test, weekly regression, sanity regression, nightly regression. Those all things uh, we will co- we will write the code accordingly. We will customize the code accordingly by using Makefile and the Python scripting. And overall, in design verification flow, we have some sign-off criteria. We will check whether all the test cases passed or not. We will check the functional coverage is 100% or not, and we will check and code coverage reached minimum criteria to sign off or not. It reached the threshold or not. And after generating these reports, we will generate these reports in different formats based on the requirement. We will generate in Excel format. We will create the matplot diagrams like pie diagrams, and we will generate the web-based dashboards. So these all now I will show briefly. You will get more clarity. Just I will open and I will show. Earlier we covered all these concepts in the last batch. So whatever the things we covered in the last batch, that all I will show now. Next, finally, we need to pipeline all these things. Like during compilation, in SOC level, when we are running the simulations, the system memory, the server memory will consume. The server memory will consume as as increasing the number of test cases, as increasing the code complexity, the server memory, more memory will be consumed. So to avoid that, we generate the RAL models. We will generate the RAL model during compilation time, and after completing the regression, the tool will automatically delete the RAL model. The tool will automatically delete the RAL model. RAL model compilation after the test case automation. For test case automation also we will do, and test bench development simulation. These are small tasks in overall design verification flow. And at last, we will measure all those things. We will measure all those things from simulation to coverage analysis, reports generation, and debugging, and web-based dashboard generation. These all things we will keep in pipeline, and we will schedule all those things without human interaction. Without human interaction, we will schedule all those things, and it will run based on the timings. Based on the timings we schedule, it will run on the server. It will run on the server, and it will generate the reports, and it will share to all the team members. And for that, we will use different Python inbuilt library modules. Python modules present in inbuilt Python library. Yeah. Now I will show one by one what we discussed. So, the analysis reports.
Shiva, tool will be useful for all, right? So tool support also you will do, right? Like which tool they will use for typing coding part?
Yeah, coding, Python coding. Yeah,
Yes, yes.
everything. Yeah, with respect to this course, mostly 95% we are focusing on coding only. 95% we are focusing on coding only. And here we are using Quasta Sim, and I'm taking internal project, AXA internal project for doing all these things like setting up regression, generating log files, parsing log files, and generating all the required reports, creating the dashboard. For all those things, I will be using internal AXA project, AXA test bench, so that I am not sharing that one. And if you have any project you can use your own project. And related to all the Python related codes, I will share all the Python related codes, notes, what I am teaching in the class. Everything will be shared. And we are using Linux environment. We are using Linux environment for doing all these tasks. We are using Linux environment for doing all these tasks. And yeah, next, for demo purpose, I will show what we are doing by using Python.
So
Yeah,
we also get tool support, right? So tool installation also you will support, right?
yeah, tool installation, but Python we need to install different dependent libraries, and Quasta Sim also how to set up Quasta tool, and how to invoke the Quasta tool from the Linux terminal. So these all things are part of this course. Next, this is the SOC level project. For example, SOC project example name I took like project root, and inside this project completely generated by tool on Python script only. So CI for continuous integration. This is related to regression, and design folder, results folder, scripts verify. Design, it will consist all the RTL files. These all folders, files, and everything. RTL verification engineers won't code RTL, right? So that's why just created the folders only. Just created folders only. This PCI, and this is RTL top. And in results, we created log file reports. All the reports, log files, waveforms will be stored on the respective folders. And here we will keep log regression script, log analysis script, and a report generation script, automatic mail. So all the scripts we will keep in the script folders. And this is main verification related folder. Here we have uh, three IPs, APB, AXA, and PCIe. And in each IP, we have many subfolders like agent. Inside agent, all the agent related files. And in each agent, there is the code, common code, right? For each agent, across all the test benches, we have a common code. So that all common code will be automated by using the Python script. So like this, by using Python script only, we generated all these things. Python script only, we generated all these things. Like this, in your project, if you have three interfaces, one is three IPs, one is APB, AXA, PCI, but in real time at SOC level, we have many IPs, many IPs. So to code all those IPs, to code UVM based test bench for all those IPs, manually it will prone to the errors. So by using the Python script, we can automate overall test bench skeleton. So that time the Python scripting is very useful. Next what we covered. uh, Log analysis reports I will show you. The log analysis report we generated Excel based reports. This is the test case names like sim1, sim2, sim3. Like we generated, uh, we analyzed 50 test cases and we reported like what is the error count, fatal count, what is the status of test case. If you want report in Excel format, we can generate Excel report, and otherwise if we want CSV format, we can generate CSV, and by using matplot we will generate pie diagrams like what is the what percent of test cases failed, what percent of test case passed, error percent, fatal percent. So everything we will generate like in a pictorial form. So it will be easy to come to the conclusion whether we achieved sign of criteria or not. So this is regarding regression and log analysis. Next, RAL also. Uh, so this is RAL model at SOC level. This is RAL model at SOC level. This is RAL model at SOC level, and in SOC we have IPs 30, 40, hundreds of IPs are there. In at SOC level, we will have hundreds of IPs, and for each IP there will be the internal registers, and all internal registers are mapped at SOC level address memory. All internal registers are memory mapped registers. At SOC level, each IP has memory mapped address registers, and by communicating with those internal registers of IPs, we will do the different transactions at a SOC level. So for that, we need to implement SOC level register model. So we will see how many lines this file, how many lines of code this file consists. See this file. This is the file RAL model file at SOC level, and it took more than 1 lakh lines of code. It took more than 1 lakh lines of code. So to code this many lines manually, it will prone to the errors. And if we get any errors, compilation errors, it will take more time to analyze and debug. So, but by using Python scripting, just by within 1 second, just by one click, we can able to generate this many lines of code. So this is at SOC level RAL model, and it has many IPs. So this is SOC level register top level register block, and Inside we have the many IPs like END, clock, generator, AST, flash controller, GPIO, register block. So for each IP, there will be register block at SOC level. There will be top register block. So these are instances of individual IP register blocks. So this all code will be automated by using the Python scripting. This is one application. This is one application. Next. Yeah. Next, we will generate the dashboard. We will automate those all things, and we will generate the dashboard. And dashboard will show all the final results. Dashboard will show all the final results. So here, so this is already this one not included in the dashboard generation, not included in the last batch. Yeah, I will show the script. We developed a script already. We developed a script, so I will run this code and we will see output. For example, I took one example. It will generate. So this is a final report for SPI IP, SPI regression dashboard, and it will show all the test cases like this. For example, for demonstration purpose, I took only 5 test cases, but we will integrate actual AXA test cases, and we will generate this report. So it will include all the test cases, pass fail criteria, how much coverage achieved for each test case, and what is the runtime each test case took. Like we need to know how much time is consumed for each test case. If it is exceeding uh, if it is exceeding the threshold time for running each test case, the time we need to check for timing issues. And we can also filter fail test cases, past test cases. So this is coverage based test case. For test case achieving how much coverage. So this is test case 2, we are getting coverage 70. Test case 4, we are getting coverage 55. And yeah, this is for fail scenarios. Test case 2, it's taking 15 seconds, minimum 15 seconds. Test case 4, it is taking 20 seconds. So we will know for each test case how much time required. If it is exceeding the required time, required threshold time, then we need to see any timing violations are happening or not. So for better observability, we need to generate. We are generating this dashboard, and just by seeing, it is easy to analyze how much we achieved with respect to required sign-off metrics, how much we achieved the coverage, what are the test case failing, passing. So it is easy to visualize these things. So finally, we will generating the dashboard and completely from simulation to regression setup, log analysis, report generation, everything we will pipeline, and by using cron job scheduler, we will schedule these all tasks for particular based on the requirement. We will schedule these all tasks. We will schedule these all tasks in the pipeline. This is runtime for the each test cases. Finally, we are displaying a summary like total test cases are 5, passed test cases are 3, failed test cases are 2. Yeah, these are the things we are going to cover in this course. Yeah, yeah. Anyone has any doubts regarding the course?
Hello.
Yeah,
Yeah,
hello.
hi
There.
Siva. Yeah, Siva. So my question is like, the Python is prerequisite for this course, or what will you taught
No,
there?
yeah, yeah, yeah. I will clear that. I will clear your doubt. In the course, we mentioned the basic requirements is that everyone should know the basic commands, how to navigate through Linux terminal, how to use the Linux terminal, and GVim. And yeah, it's better to having good understanding of what is regression, what are log files, what are the simulation tools, like basic understanding of verification flow.
Yeah,
And
yeah,
next in the
actually, yeah, one thing. So one thing, yeah, that is the purpose we are not allowing for freshers in this batch, because freshers really they don't know what is log file, what is regression. They don't know registers, like what is registers, either inside IP block registers are there. So and employees they know basic Linux commands like cd, ls, make, how to create folder, how to grep any words by using grep by hyphen inr or CD or LS or MKDR. These basic things we want, and that's okay. Some Python related what we need to code, that initially Shiva will explain some of basics of Python. Then only first day class only we can't go directly. Oh, today we are going for setuping regression, like that. We didn't start first 5 days, 10 days. It's a bit we will discuss some Python basics then, because this is common doubt but that is the purpose we are also allowing only for employees, because if freshers also we got lot of requests. Freshers they don't know what is log file, what is regression, but our coaching is not for freshers, like bit advanced, this coaching is mainly lead or leading position, because in industry side lead only need to maintain all the coverage reports, lead only need to maintain all the this regression reports, but nowadays industry side who all are have scripting knowledge, their image only it will be different. For example, I saw like in our company only, or I saw around one team, one person bright in scripting, everyone look like he is master, he can able to manage anything automated scripting language like that. So that way scenario will be present in industry side. So that is the purpose we are also allowing for employees. So we are going bit advanced way of teaching that you already know, like in what Shiva explained. So that basics we are expecting. Yeah, Shiva. Sorry, please try to continue.
Yeah, in the course initially, first 2 to 3 classes we are going Python basic only. So Python basics means what are the concepts from Python required for useful for developing the Python scripts. Then Python there will be many modules and many syntax, but we are learning only the basics required for developing the scripts. So see first class we are covering Python essentials for VLSI automation, Python basics like what are the data types we have and what is the syntax and how to comment, how to handle the different string types. We have different data types like list, tuples, dictionaries. And next we will in second class we are covering again basics like different control statements like if else, for while loops, different loops. And next we are going with the functions and error handling in large coding to see in some cases we will get in Python, some cases we won't get any error, but still the script won't execute. The time to know what is the issue, we need to maintain some syntax. We need to maintain some syntax for handling that file. When we are working with the files, that time it won't throw any error, but it also won't give any output. To handle those type of errors, we have the try execute finally blocks. So that we will cover. And next, to accessing the files, different format files like CSV files, XLS files, we will cover. So we will next this one up to class six, we will cover all the basics like Python, how to create module, how to reuse the modules. Up to class six, we are covering basics only. What are the basics required? Those all basics we will cover up to class six. Yeah, Vicky, it's clear.
Yeah, it's clear now.
So and Nalina asking, do you provide Questa license for access? So Questa is now openly available, like in Google. We will share link. You can download.